Okay, this is the Global Script Syntax Overview, Part 2. Still on the HSGS syntax. I want to go through this is the GSDL TypeChecker module. This defines the core functions of the TypeChecker, so the infrastructure, the functionality underlying the TypeChecker, and then the type checking logic is in the GSDL TypeCheck module. So, interesting things. I'm going to assume that you've seen the Part 1 video. I'll include a link in the description. Let me see. So this is working in the TypeChecker monad. Unlike the parser monad, which is interesting if you think monads are just for imperative programming, this is basically just a standard imperative monad. It handles, it manages a type environment for you, so you don't. It manages a type environment automatically. So you get the same type environment passed down to every statement in a block statement, and you can augment the type environment in a block structured way. So it's sort of like having the type environment in a global variable, but it's not global. It's actually controlled, but it's controlled under the hood. So you get sort of the best of both worlds. You can see here in the real language, this will just be analyze m, but that depends on type classes, which depends on the type checker, and HSGS has no type checker. The first time I've written a global script type checker for this round of the implementation. So we can't really do that. So this is not the best name. It should probably be TypeChecker.hsgs, but that's not what I decided to call it when I wrote this. And so what this does, analyze m, you say analyze because this is a value, but TypeChecker getVar is an action in the TypeChecker that's going to look up what is currently stored in the variable or the reference v0. So you use analyze m instead. So that handles the fact that the scrutiny may return a different value each time, and it makes sure that your cases are in the correct monad, and it makes everything work. So we're looking at that. It can return nothing, which means that this unifiable variable is just a variable. In which case we need to look at the second type. If it's also a unifiable variable, the first thing we want to do is check if they're the same variable. Because what we're doing is asserting that ty0 and ty1 are the same. If they're the same variable, then we want to bail out. Otherwise, or if ty1, so we have underscore patterns for match anything. If they're not the same, we want to call unify var, which is going to handle it's going to handle setting v0 to ty1, except in one case that I'll mention in a second where that actually causes problems. So we've got, just like parser for, we've got TypeChecker.for for the TypeChecker monad. God, you can see I haven't written every single case for the unify function yet, but you've got a general pattern. Check for the case where the two types have the same constructor. Check for the case where the second type is a unifiable variable, and do the unify do var, and then anything else is a wrong type and give a type error. Really, this case and this case, there's no real need to repeat these, except that GlobalScript's definition by cases, or HSGS's definition by cases, because it depends on these analyze expressions, and because I don't have structure literal or tuple literal patterns, it's not quite as powerful as Haskell or ML. I'm going to fix that, but it's not really worth fixing in HSGS right now. So I'm hoping to at least get the HSGS to HS program rewritten in GlobalScript, and then spend time fixing things like that, because it's a minor annoyance. It's an annoyance, but it's a minor annoyance. Again, there's a TypeChecker.unit. So eventually that's just going to be analyze m. This is just going to be map m. But again, we need type classes for all of that, or at least a type checker. I am a fan of type classes. It doesn't make me comfortable. I don't like the idea of mapm not having a principal type. And honestly, I'm not comfortable with the idea of mapm not having a single meaning. I don't like context-dependent meanings. I don't like context-dependent word meanings in English, like in natural languages, and I really don't like context-dependent word meanings in programming languages. I don't think that's a good idea to adopt into a programming language. I want to know exactly what variable is this, where is it being imported from, what does it do, what does it mean. And if it's something like plus that, well, it's the addition for the type that it's operating on, that's fine, as long as I can explain, okay, what is the plus method for this, what is the plus method for this type supposed to do? I want to have a structured form of overloading, but having three different plus operations that don't fit into a type class, it makes me nervous, and I don't want to support it. I don't want to allow it. And type classes are cool. You can pass type class instances to things. You can write a generic sort function that compares its arguments, compares the elements of the list the way their type wants to be compared, or you can override the dictionary and pass an explicit comparison function into sort. So, yeah, type classes are good. The other thing that Idris does, pretty much everything that I'm not here to rag on other programming languages, just want to explain GlobalScript, but the other thing that some programming languages do, where they just let you import names and resolve the ambiguity based on types. We couldn't really do that in HSGS anyway because there's no type checker, but I really don't want to do it that way in GlobalScript. mapm has kind of the wrong argument order for my programming style. I would be happier if it took the arguments in the other order. The best syntax best syntax that I have would be something like that. Oops. Put that in the right place. This is the best syntax that I can come up with. I guess in real global script that would just be units. This is method call syntax. So this is very, very specifically for, this is something that the object on the left-hand side knows how to do in itself. And it's in the nature of lists that they should know how to do map, they should know how to do mapm, they should know how to do fold-L, or fold-R, I mean, folds in general. A list is, the list type, list alpha is the free monoid over alpha. And of course, a free functor is a left adjoint of a forgetful functor. You don't really have to know what it means, but what that means is, when I say that list alpha is the free monoid over alpha, that's the same that means that a monoid homomorphism from alpha to a monoid W is the same thing as a function from list alpha to W is the same thing as a function from alpha to W. So if I've got a monoid homomorphism, I can apply it to a function alpha by composing it with the singleton function. And if I've got a function from alpha to W, I can raise it to a monoid homomorphism from list alpha to W using fold map. And that's sort of that's what folds are doing. So folds in particular, and a map is of course just a special case of a fold as well as being important in general. Folds are intrinsic to what a list is about, the concept of a list. So they definitely would make good methods. And then, in my mind, the method name mapm is a different name for each object type. And so I'm okay with ad hoc overloading of the types of methods, where I am not okay with ad hoc overloading of global functions, things that are supposed to be objects. But I don't know how to take something that has the same arguments as mapm and fix the argument order. So it's a problem in general. There's never any perfect argument order that you should always use for a function. But in my usage, I tend to use inline lambdas for the first argument to maps and the first argument to folds, and that tends to not work out very well. It just looks ugly. I don't like splitting them out into named functions. I don't think that's a good solution. I mean, this is what COBOL does, right? COBOL takes the body of loops and splits them out into separate paragraphs, and you just have a run that paragraph over there so many times or until this condition is true construct. And it doesn't work. It's really stupid. Like the body of a loop should be part of the code for the loop, at least in my opinion. So I don't have a really good idea of how to fix the argument order, especially so that maps and folds, like there's an algebraic thing that they're doing, and that's useful, but it doesn't necessarily produce good code, and I'm not sure how to fix that. Something that I'm still working about. So this is HSGS. This is the type checker, the part of the code that's in the type checker monad. but there's no type checker for HSGS, so there's no new type. So in real global script, there would be a like TypeChecker.in wrapping this, but I just skipped it because there's no type. It's just there to placate the type checker, and there is no type checker. So this is the structure of how a type checker works. It takes a type environment as an argument, and then it returns an stmonad. Imp4 is the primitive for imperative constructs or procedural languages. Run this, then run that, then run that. So this is used by the stmonad. It's also used by GSI, GSIO. So we call stgetvar on V. Again, there should be, actually no, I take that back. V here is, okay, when I get a type checker, this is going to get more complicated. But yeah, V here, this is from the type variable constructor, unifiable variable constructor. So yeah, this is just a raw stref. So I do that, and then a type checker has an error monad in it as well. So I have to take this and transform it to a write, and then imp unit is the raw return in an imperative monad. Conceptually, without a type checker, there's just the imperative monad. So we wrap getVar and we wrap setVar into the type checker monad so that everywhere else we can just call them and they'll abstract out the details of how the type checker works. So we have instantiate, which is in the type checker monad because it calls new unifiable var. So this allocates. Subst is in the type checker monad. This type checker is free in. Did I skip over it? This type checker is free and it looks through unifiable variables that have already been unified, so it has to go into the type checker monad. A lot of this code, like especially for handling signatures, there's no real way that I can think of to structure the code to guarantee that we handle everything that's in a signature. So you basically just have to use tests to take care of it. I'm not sure if... I know that handwritten generics would not help. There's only a few functions in this module, and I think every one of them would need a different generic traversal function. So handwritten generics are not going to help. Auto-generated generics would help, but they'd be a lot of work. So this is just something that I don't know how to do cleanly in general. I wouldn't know how to do it cleanly in Haskell. So new unifiable variable looks inside the type checker monad implementation. One of the places we would have to update if we wanted to change the type checker implementation. Is free and doesn't, but it calls type checker getVar, so it looks through unifiable type variables. Incorrect type returns a left. This is a string. It's QQ, which is supposed to be a machine-readable string, which you can see this is not. I need to fix this. And I need to go through this module and fix it to return log.t, human readable strings. I had forgotten that I needed to do that. And then font type. This is in, again, this is in the type checker monad, so it can look through unifiable type variables. Get type. It looks into the type checker monad, so it can find the environment, and then also it'll return an error message for variables that are not in scope. Nothing syntactically to comment on here, but you can see that views are just variables. They're separate variables from variables, so you can give them different types if you want. This adds a new variable inf1 locally in A. Let's see. This is the analyze m. You can see for and analyze m are both just synonyms for bind. But what's different is that they have different signatures for the parser. So the parser parses them differently. So fold m is re-implemented for each monad, again because there's no type checker, there's no dictionaries. That will get fixed eventually. There's a fix me here. Again, there's no structure literal parsers. If there were structure literal parsers, then we would do a simultaneous pair match on x and in y's. And what I have already implemented is that does parallel pattern matching on x and in y's. So we match both of them against a const pattern. If either one fails, we bail out and return nil directly. So it's symmetrical between the two, and it's defined in as many cases as possible. But again, adding structure literal patterns to HSGS isn't quite worth it at this point because it's implemented in Haskell, and I'd rather not write any Haskell code at this point if I can avoid it. We have TypeChecker run, which delegates to st run. TypeChecker unit, which is just looking inside the abstraction. TypeChecker bind uses analyze impm, which is the version of analyze m for the primitive imperative monad, as does TypeChecker map, which is just a specialization. And then the HSGS translator doesn't support constructor variables, or constructor views. So you have to build those yourself. This is template Haskell to try to track source positions as much as we can. I think GHC8 might have a way around that. I'm not completely sure. I don't think it's as good as what GlobalScript has, but I think it has something. But this, I started with GHC7, and like I said, messing with Haskell is not my top priority at this point. So it's good enough for now. This is the raw bytecode, quote unquote. You can't see my air quotes, but This is raw bytecode for making a constructor. This is raw bytecode for deconstructing a constructor. I have no idea why I decided that this needed to take Haskell arguments instead of just returning a GS value. But again, probably not worth messing with right now. So that is everything in that file. I welcome feedback, questions. Hopefully you're not completely lost and can ask some specific questions. And I look forward to hearing back on what you think. Let me know in the comments below.